Hello, everybody. Welcome, welcome, welcome. Um, let's give it maybe 2 or 3 minutes, and then we can get started. I'm super excited for this session. We've got Feihu joining us from the Moonshot team, and we're going to do a deep dive on the Kimi K2 Thinking model that was released recently. What I like to do at the beginning of these sessions is get a poll of where people are joining from, and typically it's all around the world. So, where are people tuning in from this time? Nice. Guatemala, Chile, Edmonton, Poland, Georgia, Cambridge, SF. Uh, I used to be in Canada. I'm in SF now. Edinburgh, Pakistan. I'm originally from Pakistan. Shanghai. Yeah, awesome. Florida. All right, cool. I'm going to do a quick check to see whether we're live on YouTube. Yeah, that seems to be good. Before we begin, let me answer everybody's favorite question. The recording will be available afterwards, and slides. Feihu, if the Moonshot team and if Feihu wants to make that available, those will also be available. So we'll add it to the YouTube video description. Got people tuning in from India, Ireland, France. We've got representation from everywhere. This is awesome. Yeah, I've been super excited about this session. I've been let me put this up so that people know that they're in the right spot. Um, Ever since the model was released, I've been kind of going through using it, reading about the capabilities. Um, when the original K2 model was released, I read through the paper and the technical blog post, and there were some really interesting parts about it. And Feihu's going to touch on some of those in the presentation as well. Um, but I can't wait for the K2 Thinking paper to come out as well because um, I want to know how that agentic tool calling was scaled up even after K2. K2 had really good tool calling, and then now how they scaled it up even further. Um, and so when we were prepping for this session, um, Feihu, myself, our teams were thinking about, what could we talk about that would add the most value and insight to people that are trying to build with this model. Um, and so hopefully you'll find it useful. So we've got Turkey representation, Spain as well, Romania. There's a question here. Where is Kimi K2? I'm assuming K2 Thinking available. Um, it should be available across multiple providers. Together AI provides it. Kimi provides it via their API as well. It should be pretty widely available. Okay, awesome. So we waited for about 5 minutes, given people a chance to come in. With that, I'd like to throw it off to Feihu. Feihu, if you're ready, what I'll
Yeah,
do is we can hello. I can share your screen or whatever you'd like. If you'd like to introduce yourself, and we can go off from there. Maybe what we can do is you can have your presentation, and then Uh, I can try to collect questions from the chat, but I know we have questions that people have submitted beforehand as well. So after the session, I'm looking forward to discussing and hopefully that'll be useful for people as well.
I saw there is already some questions from our audience.
Yeah. I think if we wait on the questions from the audience, we'll be waiting all day. So I want to we'll get to the presentation, and then if you during the presentation, if you find any interesting question, you can just point it out and let me know, and we can take questions during the session as well.
So for George, you can find the Kimi 2 model on Together AI and Moonshot AI as well.
Yeah, awesome. All right, so we've got a bunch of people in here. I think we can get started. Let me bring up your slides and let's kick it off.
Yeah, I have a little self-introduction page on the slide.
Awesome. Take it away.
Yes, so this is Feihu, and I am working on the Moonshot devil relationship team. And I used to working in the alignment and the infra team as well. So I might have some basic knowledge, and I think I might be able to answer any of your question of any type. Yeah. So I'm also happen to be a trade expert at this moment. So I am uh, using mailing web coding tools and help people and answer their question as well. So I'm also a ex Googler. Oh, there's a typo. In data info team. Uh, and I also happen to be a SCM ICPC gold medal. So I love algorithm computation as well. So this is I doing a presentation last week. So before we build a strong thinking model, we need to build a strong foundation model as well. So for Kimi K2, there is some highlight. This design principle is a model as agent. So they have a strong agentic to use capability, and it uses a self-critic reward reinforcement learning algorithm. And they also have a advanced the optimizer algorithm called Moonclip and the scaling tab, and it's 1 trillion parameters and 32 billion uh, the active parameter MOE architecture. So Kimi K2 work uh, pretty well on some of the benchmark. For example, the humanity last exam, you can see it. The thinking version of Kimi K2 has a little bit higher than the Gemini 3 yesterday, and and they work well on many other benchmark as well. For example, the level code bench is many OG problems in algorithm contest and many math contest as well. So here, strong refers to the model achieving good generalization performance on some core parameters and some agentic benchmarks preparing for building the thinking model in a near future. So there is a lot of inner core parameters for the models. For example, there is max logic and grad norm. Uh, Among them, the most important, I think, is a loss curve. It's really play a crucial way in the modern training. Uh, so you can see during the Kimi K2 training, the training loss play a very beautiful curve. You can see, and as the scale of the model continue to increase, it's become crucial to make efficient use of the data as well. So the first things of the creativity of Kimi K2 is we are uh, invent a new optimizer called the moon optimizer, and it improve both the training efficiency and model performance. So you can see the curve of our experiments during the paper we released a few months ago. It's called the Moonlight. You can find this paper on Hugging Face. Another thing we must to emphasize is to uh, uh, everyone knows the data today is very hard to get for such a large scale of the base model. So we introduce a large scale agentic data synthetic pipeline to generate more data that we need and at scale. So this plays a very crucial part to build the agentic capability. So this is how to build the entire pipeline of the, the graph. So you can also find this the detail in our paper. So this one is how to generate the data so that it play a diversity over mailing data in the real world. So the last one is except the SFT, we also need the reinforcement learning to build more ability of the model. So we have built a reinforcement learning pipeline. So a self-critic reward has been used and be introduced to let the model perform pairwise compression to judge its own outputs. Its general the ability of the IL algorithm as well. So we also have a parameter updater engine for help the infer team to training the model. So once you have the foundation model, strong foundation model, and the remaining task is to construct the thinking data needed to build the thinking model. So so we have working for many months after Kimi K2 released, and just a few weeks ago we are releasing our thinking model. So you can see there it play very well on many agentic benchmarks. As I mentioned before, the HLE benchmark is slightly higher than Gemini 3 yesterday. Oh, and this is a new benchmark released just a few hours ago. You can see Kimi K2 Thinking also play well on this benchmark. And this is a real life example on how to interleave thinking during a prompt. You can see that it didn't like the general thinking model. Every thinking happened before and have one answer. And in interleave thinking, we have many thinking before we have the final answer to the users. So what is interleaved thinking? So simply speaking, it's you need to reason to again and based on the tools result before taking further action. It will have many turns reasoning during one turn with the users. So here is an example. This is old paper a few years ago. It's given as an example on the interleave thinking. So on the left, they are question what what is the director of the firm of the academic award for Best Picture 5 years after the Berlin Wall fails. So this is a question you need to have many reasoning steps. And the left one is general thinking. You can see it have the wrong answer. It give us the matrix which is wrong, and the right one gives the right answer because it builds the correct steps of the what information we need to get the correct answer. Oh, so this is a game I love very much. This is called the Three Kingdoms. So in this game, some hero can thinking twice in the battle, so they have get a lot of advantage. So so why is interleaved thinking important for agentic model? That's because in agentic environment, it's just like the problem we have showed before. It need to grab many information of the browser and of the the IDE, the coding system, and many the information to get the final answers. So it is showing some similarity between the two problems. So it is very important to use the interleaved thinking for a good agentic model today. So how to train thinking model with interleaved thinking? Uh, the most hard part is the rich and diverse thinking data. Uh, you need to grab not only the real world data, and also you need to have some expert to write the golden data as well. And then you also need a synthetic data pipeline to generate lots of data to cover every perspective as well. So after you get lots of data, you also need to improve your inference efficiency. That's because while training our thinking model, the inference play a crucial part because it will speed up your training percentage. So it's not only for the users, but also for the infer team to uh, to have the experiments quickly and get the result, so uh, uh, they can use their GPUs to train to train the model faster. So we need to have a strong and better inference efficiency. So our method is to using int4 wet only quantize, and it gets roughly uh, two speed, 2 times generation speed improvement. So I think it might become a massive adoption in near future because everyone need this technology. So some more maybe we are interesting what's beyond Kimi K2. So we need to go back the fundamental paper. It's called the attention is all you need. Everyone know it today. It's build a fundamental architecture of today's large language model. And the most important part of this transformer architecture, it's very is designed for the architecture today, so we can have the matrix mutation very fast and help with training the model quickly. So here is a self-attention function. It plays in the crucial part of today's transformer architecture. So basically, the self-attention is we have 3 matrices called Q, T, and V, and we need to to have some matrix mutation and get the final output matrix. So this is basically the standard attention algorithm, also called softmax attention. And what's the problem with the self-attention? because it's a quadratic computer for training, and it is also inference is also decoding is a quadratic as well. So you can say it's not good for scaling as well, especially for the long context scenario. So you might already notice we have just released a paper called Kimi Linear Attention a few days ago. So what we change is we the the bottleneck of the traditional attention software max attention is because it needs quadratic computing time during the decoding stage. So, and it's become a bottleneck in many perspective. For example, the processing performance and predicting latency and decoding latency. So how to solve it? So we are substitute the softmax attention with the linear attention, and so you can find the algorithm have been changed, and the difficulty has been changed as well. So you can say the computer now becomes linear during the inference stage. So it will in, engage many long context scenario. For example, you have a web coding scenario. You load a rope on GitHub and have maybe thousands of files at one time, and you need to grab the information and uh, to build another function based on what you have just read. So these are typical long context scenario. So, but why we can see the linear attention model today? That because they have many uh, the technical difficult and the engineering difficult to overcome. So one is the evaluation trap. So and another is the infrastructure of linear attention is not meet the today's software attention. For the evaluation part, you can say uh, as well, we have found a, a benchmark we need to solve. We can get a lot of improvement of that benchmark very quickly. So you can see the human last exam is only just being introduced this year, and now they got about 14 scores today. So and it's hard in linear attention because there are many variable you need to doing trade off, and you just need you just not know what is the play a crucial part of these kind variables. So there is how we choose between NOP and ROP, and the pure sigmoid or GDN style gate, and KDA or MLA. And so there is you need to do lots of ablation experiments to get the right answer. And there is lots of internal indicators. Just as I mentioned before, there is a lot of spike and grand norm and mass logic. You need to find the most important after you change to a new architecture. And once you have a long context model, you can unlock the, the ability of agent production. For example, in Kimi, we are building the Kimi Explorer Edition last year, and the Kimi Deep Research uh, early this year, and we released K2 model just a few months ago, and today they got lots of attention. And we also have released a agent product called OK Computer. So this is our the newest agent production today. So the Kimi computer, OK computer, it's just a agent model. So you can use many tools at one time. So it can not only build a website, but also build a slide and also to write some program as well. So and we after we released Kimi K2, we also have found that they have some problem of the open source the vendor. So we have released a vendor verifier for the community. So every community can find what the problem of their version. So this has been released about 1 month ago, and today many vendor has alignment with us completely, and that's a good news. You can see that some open source community already use the Kimi vendor verifier benchmark, and they got nearly 100%. And also we have doing some infer stuff, something like the KV cache, and we have just get this year's best paper reward of fast 25. So you can see today lots of open source community also use Mooncake as well. So we also have some developer story. You can see Uware and Tree also use our model, as well as the Perplexity. They just announced yesterday, so you can have it check. So here is some reference if you interested. I might release this slide after the stream. So thanks. If you have any other question, you can just follow me on tweet, and I can reply your question directly after the stream. Thanks.
Awesome. Thank you so much for diving into the details. Um, while you were going through the presentation, there's a lot of questions that we got. So I know we had a question as well that we were talking about. Maybe we can do a little bit of both. Maybe we can start off with questions from the audience here. So this is one interesting question that we got that we can start off with this one. So this question revolves mainly around how does K2's approach in running many tool calls and interleaving the tool calls with the thinking differ from what we've seen classically? Classically, all these, whether it's instruct or reasoning models, they do one tool call and then you wait another turn and then you do another tool call, right? Um, with an external orchestrator. And what I think what this person means by an external orchestrator is either the client side or the software that's handling the tool calls performs a tool call and then appends it to message and you go to the next one. Um, so how are these two ways of doing tool calling different? And which one do you think is the better one and the way of the future?
It depends on the problem type. So if you have a simple problem and it might need a simple answer, uh, so the DeepSeek I1 style thinking is enough. But however, for some complex agentic tool call scenarios, uh, especially when the problem involve interleaved thinking, we need a more well-designed reward function, and we need to have this kind of uh, interleave thinking pattern. Just as I mentioned before, that's a really simple example of a question about the movie's name. But in the real world, we have many more complex scenario. For example, you ask the model to help you to build a website. You need some very many information from come very many different source. So uh, we believe we need the interleave thinking pattern is the future.
Yeah. Just a follow-up question on that. You showed the paper that did the multi-hop tool usage. So when DeepSeek released their paper on GRPO, one of the really interesting things for the community was how simple the reward function was, right? It goes and it does its thing, and then you get one reward signal at the end, and then you propagate that all the way back to the beginning to see how you can update the weights accordingly. But in that paper that you shared on your slide, I noticed that there's a reward signal at every tool call. Every interleaved tool call has some reward that propagates back. Is this one of the ways that is required to scale up interleaf tool calling, more reward at multiple steps and not just the end stage?
Yes, because in the interleave thinking stage, you cannot just judge the result only while their final answer right. Because, for example, one function is one way to answer the question is directly, and another use overkill the method, and you can the short one is the best. So there is many perspective, and you need to build the reward function for in many steps as well.
Yeah, that's super interesting. Um, I guess one follow up to this would be when you're developing these traces of really long interleaved tool calls, is it also important to build in some robustness? So, for example, one thing that I think might be interesting would be to on step 4, maybe add a wrong tool call. And then on step 5, 6, or 7, it corrects itself. Because typically, when I'm using these agent applications like Cursor or Manus and things like that, if it makes a mistake, it'll correct itself and it'll realize the mistake and then fix itself. Do you also think about that when you're post training for agentic use cases?
Yes,
Okay, that's super awesome. So you've got some kind of concept of negative reward for the wrong tools built in there as well.
yes.
Okay, awesome. Um, okay, there's more questions here. Uh, yeah, this one's related but also interesting. So this question asks, what is the main difference between a React framework, so this reason and then maybe code and then act on it, versus this interleaved thinking framework?
So this is a good question because these two framework really share many similarity, and and for general speaking, it just the same things and being resembling in different way. Uh, in interleaved thinking, we build the thinking uh, procedure uh, after the token in the uh, token token side, and in React we also have to build in some similar things. So basically, I think they share some similarity.
Awesome. And then there's another question on, so a lot of people are interested in this interleave thinking, I think rightly so. There's more questions here as well. So this next one is also related to this. Um, this person is comparing it to the Mini Max 2 interleave thinking and Google's thought signature.
Uh, I think they are play some similar way because the most different between them is I think is how we build the data pipeline. So other thing I think is to achieve the same things to use agentic tools in one terms.
Yeah, and the other thing, we had a session with when GPT OSS was launched, and GPT OSS also does this tool calling in its thinking process as well. So that I think a lot of different labs are kind of converging on this as the way of the future, which is super interesting to see. Um, you mentioned the data training pipeline. This question pertains to this. So this person is asking, can you give some concrete examples, real world examples of the environment you use to train, and do you plan on open sourcing these?
Uh, we use some the OG the computation, the informatic computation and the mathematic computation data, and it's come from the real world. And we also have a uh, synthetic ways the problem building basically based on this real world data as well. So uh, I I'm not really know we will need open source this arena environment at this moment.
Yeah, thank you. Um, okay, so I'm just looking through some more of these questions. Yeah, I think we took this is similar to a question that we took. The first question was about React. This question is about Codact. Um, so what are your thoughts on writing code to solve a task versus just using a tool directly?
Uh, it's really different thing. I think writing code is more difficult than just using a tool. So, for example, for some hard question, for uh, solve a mathematical problem, you can solve it directly, but it's impossible for a large language model. But if you are using a tool, that will become really easy because you can just call the calculator or something like this. But if you can writing code, you can uh, unlock many things. Will be awesome in some sense.
Yeah, I think and there's a lot of other labs that think this way where if you don't have to train a language model to solve every problem in the world. If you can train it to code, then it can use coding to solve a lot of other problems. So
Yeah.
it's almost this gateway that allows you to unlock a lot of downstream capabilities. Um, yeah. I know we had this question internally as well. We were thinking about token efficiency with K2 thinking compared to K2. This question is related to that as well. So this next question is asking about token usage between thinking and answer and interleaved reasoning.
I think it depends on the problem. So we don't say there is a very many difference between these two kind of thinking patterns. So it's I think it's mostly depends on the problem of the user need to solve.
And then one follow-up question I had to this was in the Reddit AMA that your team recently did, this question of token efficiency also came up. And in that, I think uh, there were um, comments or questions about for future versions of the model, will token efficiency also be added to the reward function so that it can generate not just the right answer, but the right and token efficient answer? You can
Yeah,
answer
the
it.
right and the short answer. If you
Yeah,
are solving lots of uh, problems on lead code or code
yeah,
forces, something like that, you might find that usually the most short program is the best program as well. So I think this is gonna be important in the future.
yeah. This next question is super interesting because typically when I talk to developers, one of their main concerns is these models are getting better and better at long horizon tasks. And so if you think about it from an evaluation perspective, let's say you have some task that requires 50 to 100 tool calls consecutively. How do you go about evaluating and each step in that process and debugging it or even seeing this? So this question from George is around kind of tooling to identify problems with 100 plus tool calls. How do you know there's a problem there?
Yeah, I think we want evaluation during each step. We might set up some milestone, and we just evaluation the milestone and how fast we get to there. So that's enough.
Yeah, awesome. Um, let's see if there's other questions here. Oh, this is I think this question is interesting because so this question says for a lot of tasks, especially difficult tasks, you definitely need a planning thinking step first, and then maybe you can go ahead and interleave tool calls in the thinking step afterwards. So is this something that you considered in the training as well, where you only allow thinking in the beginning and then you allow tool calling and thinking afterwards?
I haven't seen this problem before. It's really interesting.
Yeah.
So I don't know the answer right now.
Yeah, this is almost like a hybrid of kind
Yeah,
of like the DeepSeek R1 only think in token space and then think in this interleave tool
yeah.
calling.
I think it's
Yeah,
hard to today's large language model can switch between
yeah,
these two kind of style because they are training state during their training state they think the different data. So I
yeah,
think uh, it it might be questionable. So did we need to have lots of doing some lots of stuff to achieve this kind of switching?
yeah. And I imagine the reward function for this kind of switching would also be super difficult because how do you know it's so open-ended. How do you know that you've thought long enough before you start tool calling? And it seems like a difficult problem to address.
Yeah,
Yeah. Um, okay, awesome. Let's see if there's other questions.
I think the previous problem can be solvable, but we do not know if we will get some kind of bad out bad things happen. So I don't know
Yeah.
whether we will need to try to it.
Yeah. I think one of the main themes of a lot of these questions and discussion is how do you decide what you want to optimize the model for? And then how do you build a reward function that incentivizes the model to do good at this task that you want to optimize? So, one thing that I found really interesting about the original K2 instruct model and then also K2 thinking is that its creative writing is really good. Like the style that it writes in and the creative writing is quite unique. Um, so can you talk a little bit about how you added this creative writing component into the reward function? Um, and then how does it learn to, what is different about K2 versus other models in terms of the training or the reward that you gave it to improve its writing?
Uh, it, as I mentioned before, in during the reinforcement learning stage, we are using algorithm called the yeah the let me see the self-critic pipeline. So yes, here. So we build a self-critic reward reinforcement learning algorithm. So we don't need to have the reward function by human. The model can choose whether a piece is good in the writing style. So it's something like the AlphaGo in the training. So the model can improvement itself.
Yeah, awesome. Thank you. This is an interesting question, and I think we got a similar question to this when we asked people to submit when they wanted to join the session. But if you had a magic wand, what would be one problem or research problem that you would solve to double model performance? Double, I think, is asking for a lot, but
I think to change the attention algorithm, yes. And the attention is just like the working memory of our brain. So it plays the most important part of the transformer architecture today. So if one thing I can do, I could do, I think we need to uh, to have a brand new architecture of the attention system.
I wanted to pull on this thread a little bit because in your presentation you mentioned how the current attention mechanism is logarithmic square in the length of
Yeah,
in the length of the context, and then the linear attention, of course, is big O of L. It's linear in the length. You guys managed to do long context, kind of 200 to 300 interleaved tool calling with classical attention. If linear attention, and you mentioned there's engineering problems, but if we're able to solve the engineering problems around linear attention, how much further do you think we could scale these long horizon tasks? Right now, we're at 200 to 300 consecutive tool calls. Um, let's say we can unlock linear attention in the next versions of this of the coming model. What is the main thing that you think that enables in terms of agentic tool calling?
I think if we can achieve a linear attention purely, the context window won't become a problem
Yeah,
uh, anymore because you might have the infinite context
yeah,
window and for solving every to answer every user problem. But the real world is the linear attention itself have some fundamentation drawbacks. So you can't
yeah,
only use linear attention. Uh, uh, so we have many kind of hybrid architecture at this moment. So the most critical part is how to we have a trade-off between soft math attention and linear attention at this moment.
yeah. Um, this next question is also interesting. This question is about uh, yeah, so there were some papers that were released um, after DeepSeek's GRPO paper that talked about almost this curriculum of giving models while you're training them easier problems and then increasing the complexity of the problem. So this question here um, is asking about scaling the complexity of these interleaved tool calling in the post-training process.
Yeah, this is a regular method called the curriculum learning, and this today is uh, play in many teams, as I know.
Yeah. Awesome. Thank you. We have about 10 minutes left. One of the topics that the community is really interested in, and you touched on this as well, is um, tool calling and how good tool calling is for these open source models. And to me, Kimi K2 Instruct was one of the first models that kind of highlighted tool calling. And in your paper, you called it the kind of the agentic tool calling model. And there was a separate section on this whole process. So what I wanted to talk about was the vendor verifier that you guys open source to make sure that all the providers are kind of benchmarking the K2 model across the same data set, and everybody can improve together. So my question was more around um, why do you think, yeah, maybe let's start off with Moonshot's approach. When you're evaluating tool calling and making sure that the tool calls from the model are parsed correctly, how does Moonshot actually make sure that you get good accuracy? And what does your harness or scaffold around the model look like to make sure you can parse the tool calls correctly?
We if you check the vendor verifier, so you can find in we have something called the enforcement enforcers as a guiding encoding algorithm. So it forces the model to only generate the proper tokens. So it's uh, always generating a correct schema. So many open source team have some similar things
Yeah,
with us. So we're also going to open source this stuff in near future.
awesome. So it's mainly the way you're able to get really high accuracy for tool calling is just to always use some form of structured decoding or like
Yeah.
these open source. Okay, okay. Yeah, I think that's one of the in the open source community when a new model gets released. Um, a lot of the model builders are using their own tooling and their own stack and scaffolding internally.
Yes, that will cause some misalignment.
Exactly.
So
This is I think why this is great because when companies like Together that are serving models and then Moonshot can kind of work together to make sure that the reliability of the model is really high, then the developer community wins from that, right?
yes, we
Uh,
have already noticed it, and we are working on it.
yeah, and I think this is Moonshot was one of the first companies that actually came out with this opening up the benchmark so that all the vendors could actually verify that the model is as good as the model card and the benchmark say it is. So that's a really good service for the open source community. Um, let's see here. Oh, let's see if there's any other questions in the chat actually. One question I had maybe from my list of questions was around, and some people noticed this when labs started training models for tool calling specifically. Um, People, when you use that model for general purpose tasks to write a story or to summarize, people found that the model was uh, over calling tools even when it didn't need to. So the way that I thought about this was maybe when you train specifically for tool calling, you're degrading performance on non-tool calling tasks. Did you notice this when you were training K2 Instruct and K2 Thinking, that if the post-training is overly geared towards calling the right tools, then for a task that doesn't require calling tools, that just requires, outputting tokens, was it overly eager to just call tools even when it didn't need to?
Yes, that's a problem because there is no free lunch
Yeah,
generally. So you need to resolve this problem, this kind of problem during your develop stage. So maybe you need to build in some scale package, the tool package, and then you only load the needed one during some stage. So as I know, mailing agent startup have this kind of tools package mechanism today.
yeah. One more question that we got here is, uh, so this question, how do you do multi-turn task generation from just a model context protocol tool spec?
Uh, I think it's behind it's right on the data pipeline. So we already have this kind of data, so the model can know how to uh, have a multi-turn task generation in just one MCP tool specific.
And another question um, around this is, and this question gets into the conversation that a lot of businesses are having right now versus should they use a really large model that's good at tool calling, or should they use a small language model that's good at the tool calling that they need for their domain? So this is more of a question
Yeah,
around,
I think it depends on the problem you need to solve. So if you have a simple problem, the small one, the mini one is enough. But if you uh, have a complex scenario and the mini one might can't solve it well. So the large language model is important.
yeah. I also know that some of these agent tooling and
Yeah,
agent.
for example, if you only need to have some match some data and to doing a diverse uh, something writing data job, you only need a mini model. It run faster and can solve your problem as well. And in some IDE, the web coding scenario, you maybe only need a small model to have the tab function. Uh, but if you need to write actually code, you need a large language model.
Yeah. And then what I've seen some of these agent software companies and applications do is that you can also have a small model as a tool that's exposed to the large model. So the large model can call the small model to solve a specific problem, and then it gives a response, and the large model is kind of orchestrating this multiple.
Yeah, not only the small language model, but also some multimedia model. So you
Yeah,
can read the picture or draw a picture. So something like that.
yeah, yeah, exactly. Um, this question is about we you touched on curriculum learning, so this question kind of dives a little bit more into this. Um, so they're asking about, do you break down different types of tasks, different types of problems when you're trying to train this agentic tool use?
I think the answer is yes. uh, I think break down the problem into smaller ones, not only efficiently but also can faster your training passage. So and it also be easier to have an evaluation. So I think is important.
Yeah, awesome. Um, so I think I've gone through multiple questions from the chat. I've gone through a bunch of questions that as I was deep diving into the model as well, I was thinking about. Um, if there's any other questions, we have a couple of minutes left we can take from the audience. Um, if not, I'd really like to thank Feihu. This model, K2 Thinking, was awesome. A lot of people are beginning to use it, and I really think this interleave tool calling and with reasoning is the way forward because of how robust it makes the model. Um, and so it's not just thinking in token space, but it's thinking in tool space, and that tool space is as simple or as complex as you need it to be. So I really want to thank you for deep diving into that and taking us through how you train this model. Um, and yeah, follow Feihu. If you have questions afterwards, feel free to reach out to myself or Feihu. But I really want to thank you for coming on and deep diving into this.
Yeah, thank you.
Thank you so much, everybody. I hope you found this useful. See you guys next time.
Have
Bye.
a nice day.
Bye.
Bye.